Hello, welcome back. I'm sure you enjoyed that short break. Now let's get into the IDE and I'll show you how to write the byte read program for today. Continuation from the last session. So I'll minimize this. And the IDE is already open, so I'll open. This is where we left from the last session. What I'll do is I'll simply copy and create another project. So paste. It will ask for a copy project name. So today is day 24 and we are on part 2. I'll copy that. Okay, so we don't disturb on part 1, so we are going into part 2, and I'll also close the previous files in case if we get mixed up. So go to main, open this main.c. Okay. So this is the program we have written for the I2C1 init. I will minimize myself so you can see the full screen. Sorry. Yeah. As you would know, the last session we did the I2C1 init and we enabled the clock access for the GPIO port and the I2C1 port, and we set the alternate function and the output type as open drain, and we set the internal pull-up for both PB8 and PB9. Then we defined that and connected to the I2C1 with the alternate function and enter the reset mode and come out of the reset mode and set the peripheral clock and set to standard mode and configure the T-rise and then enable the peripheral, and we call that in the main program. So today in this session we're going to learn to write the next part, which is the byte read. To do that you need to define more macros. So I'll go and start with defining the more macros. I'll give it a space, macros for byte read. So as you know, you need to write with define first is for the control register one. Has defined, so you need to start with the start bit, control register 1, control register 1 start condition, and as we learned from the theory, it's the 8th bit. You need to enable that. I'm a little bit lazy, so I'll just copy and modify this for the next. Then you need to start with the peripheral enable, make sure that's in the disable mode. So that's the first bit, so you need to enable that. Then you need to do the acknowledge. So CR1 underscore third register bit is acknowledge. That's the bit 10th bit in the and then the stop bit, control register stop. That's the 9th bit. So if we go, this is what I did with CR1 macros. So this 8, 0, 10, 9, start, peripheral enable, then acknowledge enable, then stop generation. Okay, so now you can define the status registers. Macros for status register 1. So SR1. You got to write from define SR1 underscore the SP bit. You know the SP bit, it's we learned in the, now we're going to do the macros. First with the start bit and the address bit, and then the TXC bit and RxNE bit, so 01762 and the byte transfer. You have to define all of that. So the start bit is bit 0, 1 unsigned 0 bit. I'll copy this and use it for the other 4. Control C. This is the address, ADDR, and that's the first bit. And this is the transmit enable, and that will be the 7th bit. And this will be the receive not empty bit on the 6th bit. Then we finish with the byte transfer bit, that's the 2nd bit, BTF. Okay, BTF. So now we define the SR1 register, so now we need to define the S2 register as well. Macros for status register 2, so that's SR2. It's just to set that bit to say BC as defined. We're using SR2 underscore the BC bit, and that's bit 1, which is this bit, the BC bit 1U1. So we enabling this. Oh, sorry, you have to always give a space, otherwise you get an error. Make sure you got a space. Yeah. Okay, so you define the excuse me. If you define the status register bit, now you can also define the macros for the ADXO, but we will see that the ADXO tomorrow or the next day session. But let's start with writing macros for ADXL345. We'll start with that, and I already downloaded the data sheet. This is the ADXL345 data sheet. So this is where I'm getting all the necessary information about this. That's a pin configuration of the accelerometer. As you can see, we're using the pin SDI and SCL, and this is what you will see about the different characteristics of ADXL and the theory behind it, the theory of operation, what happens. The serial communication can be used as a SPI as well, but we are using it for I2C, serial communication I2C. So this is how we interface. and these all the specifications of it. This is the standard time for the every pulse and the interrupts it's generating. So this basically tells you what that particular mode is, and all these hex codes, the device ID 0x00, we're going to use that, and all the x-axis, y-axis, z-axis we're going to use. Likewise, the data x-axis data 0 to z-axis data 1 we're going to use as well. So this is where I copied from and pasted in the presentation. Register map. So these are all some of the registers in the application. So please download this, and it will be useful for you to follow. So I'll start generating this macros. Has define. First is the device ID, which is, you can give any name as per your convenience, because whatever you use here, you're going to use that in your function as a substitute. So device ID register, as we learned, it's 0x00, and we need this for several lines, so I need to copy this, and I will. The next is the data format register, and its hex code is 0x31. And the next one is the power control register, 0x2D. Its hex code is 2D. Power control register. Yeah, and then the data start address. When is the data going to start? Data start address is, it starts from 32 and goes till 37, I think. 32. And then you need to give the device address. So device DDR address, and that's device address is 53 from the data sheet. And after the device address, you need to give the measurement of 4G measuring. We are measuring, so 4G, and its hex is 0x01. Then you need to reset and the set measure. As define reset. The reset is 0x00. Then set measure. Set measure 0x08. Okay, we defined all the macros for now. So now let's first start from writing the I2C code. Also, yes, SR2BC, we have written that. Next step, we're going to write a function for byte read. So declare a function function void I2C1 underscore byte read. Then you need to pass the characters, the arguments. So you're going to send that to serial address first, and then the memory address, then the data. So we declare that function declared, copy that and write the function. Then open the function. Okay, so now I'll type in first all the necessary steps it needs, and then we'll go from there. First we need to create a dummy variable, so I'll start that and then write the types. Volatile int temp, a dummy variable that we need to use in the program. First step is wait until. I'm going back and I'm going to copy all the steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 steps. I'll copy this and paste it here. Wait until bus is not busy, and to do that you got to just write a simple while function. So while of I2C1 the status register, because that's the register we used for the busy, and you got to just simply AND that with the I2C, and sr2 underscore busy, then wait until it's not busy. Yeah, okay, so that's the first step. And the second step is you got to generate the start condition. Generate the start condition. To do that, because we need to use the CR1, that's a start. So we got to copy this CR1, come here, paste it, and you have to put that in the, you have to basically link that to the I2C that you are using. I2C1 CR start, and you just simply R, you got to set that by CR1 underscore start. Oh, sorry, C I2C1 CR maybe showing this error, syntax error, CR1. Okay, I'll fix the syntax error. I'll first start typing so we won't miss the flow. Okay, yeah, has to set the break. Start. The breakpoint. Okay. Okay, the next step is you got to wait until the start flag is set. Wait until the start flag is set. To do that, just put it on a while loop. While this time you need to say it's not equal to the I2C1 of the registers SR1. So we are setting the flag I2C1 and we setting with SR1 this bit, and then set the flag. To set the flag, you just simply AND that SR1 underscore the start bit you need to set. Okay, so that step is done. The next step, you have to transmit slave address and write. Transmit slave address and write, meaning the read write, you have to set this as 0 is right. To do that, you need to just link with the data register. Need to see 1 data register with the slave address. Okay, so it may throw an error at this stage. We haven't defined the data register, but we'll do so shortly. I'll finish all the typing and then I'll go and include the DR. Okay, the next step, you have to, after it transmit, you wait until the address flag is set. Wait until the address flag is set. I'll copy this because it's also going to be in a while loop. So while of not equal to I2C1, it's linked to the status register 1, I2C1 linked with the status register 1, and just simply AND that register with address SR1, SR1 underscore ADDR, and wait until it's set. So we are using SR1 ADDR. First we started the SB, then ADDR, SB ADDR. So the next step is we are transmitting address. Then we are just clearing the address flag. Clear the address flag via the dummy variable. So this is why I created the volatile int temp. So use that temp equals I2C1, you're clearing the flag of status register 2. Okay, the next step, you got to send the memory address. Send memory address to the data register. So I2C1 link to data register, and this time the argument here is it's M address, memory address. Okay, so that's done. After sending the memory address, wait until the transmitter is empty. Wait until the transmitter is empty. for this, put it on a while loop as well. While of not equal to I2C1 linking with status register 1, because this is where the TXE is. You're writing this TXE 7th bit. You simply AND that bit SR1, and that bit with TXE transmit enable. I2C1 SR1, you are simply enabling that with, then wait for it to being empty. Then the next step is you need to generate the restart again. Generate a restart by doing I2C1 through control register. You just have to simply R to restart it. CR1 underscore start. Okay, so that's same step. So that was the error, because I just copied the define label and put it there. That's the other error. Okay. So the next step, we finish that, generate the restart. Now wait until the start flag is set again. Wait until the start flag is set. So you know we use this, so just copy this and then paste it here. So that step is done. The next step is you need to do what the transmit slave address. So this is where you're sending the I2C with the slave address, and then you need to make it to read. Transmit slave address and read by setting read write bit as 1. If you set as 1, then that means it's a read. How are you going to do that? By I2C1 linking with the data register, and then data register and S address one, and you just simply R that with 1, means it's set to read. Okay, then wait until the address flag is set now. So wait until this option, wait until the address flag is set, is the next step. Copy that, wait until the address flag is set. Then now you need to disable the acknowledgement. Hang on one sec, just checking whether I missed any steps. Byte read, okay, so far going well. So the next step is you need to disable the acknowledgement. Disable acknowledgement. How are you going to do that? By linking I2C1 to the status register, sorry, through the control register 1, and you got to just simply and then negate, and that will disable it. Negate that bit. Which one? The crk underscore ack, which will be, you can copy this cr1 underscore ack. Okay, so that's done. Then you need to clear the address flag by the temporary clear the address flag via the dummy variable. The dummy variable is temp. How are you going to clear? It's just temp I2C1 and just service registered to status registered. Okay, so the next step, you need to generate the stop because we sent everything, so now we got stop. I2C1 linking with the control register 1, so you're going to just simply add that with cr1 underscore stop bit, stop condition. And then the next step is wait until the receive, wait until rxne bit is set, flag is set, is set. To do that, put it on a while function, while of not equal to I2C1 linking with the status register 1, and you just simply AND that with rxne bit, simply and sr1 underscore rxne, wait for this to be empty, the flag is set, wait for it. Then read the data from the data register, then read the data from the data register by just giving the data pointer equals read from the I2C1 of data register. So I think now we created the program, it should work now. So I'll save this and compile for any errors. Save, go to part 2 and build the project. It's on 19%, it's generating, so just only one error. I'll also do the debug setting as well. Debug as, debug configuration. Make sure you link that to the correct file. So STM32 application. Today is on part 2. So go to that .elf file. So browse. It's on the desktop. I2C target Day24 and debug this part 2 ELF open. So that's the link you need to set to part 2 ELF. Okay, and then the debugger, make sure you enable the ST-link and also the serial wire viewer. Apply debug. This will change from the C++ perspective to debug. so that you can view all the status, special function registers and the other registers. So once this is done, then it will be ready to debug, which we are not going to see today. Okay, with this I conclude for today's session. The next session you're going to learn about the burst write and burst read, and then the other ADXL interface. So we finished all these steps and 0 errors, which is always good. So continuing along the main program, which you will learn tomorrow or the next day. So this is what we learned. We learned the recap of I2C, and today we write a code for I2C byte read, which was really good, the lengthy process. As I said, you also have to build your mind as well when you develop your skills. So do the right thing all the time. Think always positive. So when you start to think, your subconscious mind will only look for positive things, and everything positive will start to flow. Whatever the negative or the past, forget the past. We have to learn from the past. We have to move on and make it how it's possible to make it happen. So always think all that negative thinking process and remove that immediately from your mind and start thinking positively, and that will keep the energy, positive energy, flow with you. And whatever you indulge with, whatever you face with, everything will be positive from there on. So please start to practice that. And also don't forget the mindset involvement. Write down your top 10 goals, write down your top 10 ideas to achieve your goals, and please do spend 30 minutes to do some exercise, and do spend 15 minutes to do some meditation, and do 10 minutes of visualizing actually you achieved all those goals. And then spend another 10 minutes to write down your daily plan activities and use that. And also 2 points will get you for your 2 hours of learning. Please do post all your achievements in this Facebook group so that it is for your own benefit. It will also help others to motivate and also learn from each other. That's why I ask you to do it. So please do. And there is combo internship coming your way. I don't want to put everything in one big course, so I divided into small 10-day course. So please purchase on all the 3 courses so you will learn the whole Cortex M4 series. And also please stay tuned with us. These are all the courses in progress. You will be the first person to know once they are available, so you can also enroll to that and upgrade to your skills. I thank you sincerely and honestly for all your patience to go through with me to learn another session in I2C. Please go and enjoy that lovely break from the screen. This is Arul Anbukarasu. I'm signing off on behalf of A2DG. Huru for now. I'll catch you in the next session. Until then, take care. Bye for now.